And under that valley, well, we need some geology. Under that valley, there's stone, and then there's a valley carved into the stone. And over that stone is sediment, and down here we have bedrock, solid rock. And in the bottom of the valley, we have a river. So here's my river, and that's what we'd like to cross. And back in the 19th century, someone built a road that zigzagged down the side of the valley, and then they threw a short bridge across the river, and then they zigzag up the other side of the valley and go onward. But nowadays, in the 1960s, someone said, let's put an interstate highway in, and the interstate highway has to do that. So my problem specification is that line across the valley. That line is the line my highway is supposed to follow. And my problem for the engineer is, how do we build a bridge across this valley? So the engineer has some choices. The engineer can build deep foundations or shallower foundations. We can build a tall tower here, but then we have to dig way down. Or we can go back to where the bedrock is shallower and put a short tower there. We have a lot of choices. And so the engineer has to do some design thinking. Maybe the engineer decides, we're going to spring an arch across this bridge, across this valley. And specifically what we're going to do is we're going to spring an arch where the pressure of the arch rests on bedrock there and there. But of course, we have restraining forces that we get by virtue of dirt. So we can have a relatively vertical foundation here and a relatively vertical foundation there. And then we're going to spring an arch. And the arch will be, I don't know, some sort of a catenary arch. That's really badly drawn, but that's okay because this is just a sketch. So this segment of the arch, we can build a wall there and a wall there. And back here we'll put fill. Back there we'll put fill. And then we'll have some kind of a suspension from the arch across there, and we'll have support towers there. And that level of design is the top level design that's typically done by an experienced engineer who's built 20 or 30 bridges in the past, first as a junior engineer, and then he's designed several large bridges, small bridges, and then he moved up to larger bridges as chief engineer of projects. That engineer's had a lot of experience, and based on intuition, that engineer can look at the cross-section of the project, of the cross-section of the river valley, where the river is, where the bedrock is, and decide that this is going to be a good design. And that engineer thinks of that stage of the design as art. And then he says, now let's get down to nuts and bolts, the real engineering. And for the real engineering, we're asking questions like, how thick is this retaining wall here? How thick is that retaining wall there? How heavy is the roadway across the valley? How heavy are the supporting elements here? And given all that information, how much force is this arch supporting? And given all that information, what's the cross-sectional area of the arch at each point along its length? Because we have to know the cross-sectional area up at the top of the arch in order to figure out how heavy that is, to figure out the force it applies to the next level, to figure out the force it applies to the next level, to figure out the force it applies to the next level. So now we need to know what is the force, the sideways force on the foundation at that point, and the vertical force on the foundation at that point. That can tell us the area of the foundation. What's the bearing strength of the rock down here? That's all detail work. Nuts and bolts. How many rivets to point, how many rivets or bolts to put to suspend each of these suspension cables? How do you attach the suspension cable to the deck? The detail work. That detail work looks like coding. That looks like what programmers do. That's what's consuming hours and hours of programmer time.